Hello and welcome to this video lesson where we'll explore how to add and subtract fractions with unlike denominators. Our learning goals are: I can recognize two fractions with related denominators. I can determine the factor that relates one denominator to another. I can express two fractions with common denominators, and I can add and subtract fractions. And our language goals are: I can talk about adding and subtracting fractions using words like numerator, denominator, add, subtract, sum, difference, multiple, factor, LCM, or least common multiple, and GCF, or greatest common factor. Let's think about how we can model the addition of fractions with unlike denominators. Imagine we are asked to find the sum of 1/2 and 1/4. We'll start with a model of 1/2 like this. Next, we'll add a model of 1/4 like this. Then we'll think about putting the pieces together. Now, we ask ourselves, what does this fraction actually represent? It's not 2/2 because that would look like this. And it's not 2/4 because that would look like this. And neither one of those looked like the model that we made. What if we just added the numerators and denominators? Well, that would give us 2/6, but those pieces aren't even the right size, so we don't have 6 in our model at all. We'll need to take a different approach. In order to solve this problem, we need to change the size of the pieces so that they're all the same size. Let's take a look at 1/2. How can we change it so that all our pieces are the same size? Did you say cut it in half? If so, give yourself a pat on the back because you're right. Now, when we look at our fraction, we can see that the orange pieces are the same size as the pink piece. Now let's rewrite this fraction as 2/4 to match the new picture. And we'll keep this fraction as 1/4, which matches the picture we started with. Now we have an equation where the denominators are the same, in this case, fourths. We keep the denominator the same and just add the numerators. That gives us 3/4. Let's try a different question with different models this time. Here we're asked to find the sum of 1/3 plus 4/9. Let's model that with fraction bars. We can see that our pieces aren't the same size again, so we'll have to try to break that 1/3 piece into some smaller pieces in order to make this work. What size pieces should we break the 1/3 piece into so that we can solve this problem? Did you say 9ths? If so, give yourself a nice pat on the back for getting the answer right. Now we just need to rewrite 1/3 as 3/9 to match the modeled fraction strips. Now that we have the same number of parts in each fraction, in other words, the denominators are the same, we can easily add the numerators, which are represented by the green colored parts in the fraction strips. So we see that 3/9 plus 4/9 equals 7/9. We can also see that once we have a common denominator, adding fractions is as simple as adding the numerators. 3/9 plus 4/9 equals 7/9. Let's try another one, this time without models. We're asked to find the sum of 1/8 and 1/2. We remember that the first step in finding the sum of two fractions is to make the denominators the same. In other words, we need to find a common denominator. To find a common denominator, we need to find the least common multiple, or LCM, of 8 and 2. To find the multiples of 8 and 2, we list the first 4 to 6 multiples of each number and see if we can find any that match. If we don't find any that match, we keep listing multiples until we do find ones that match. To do this, to find the multiples, we can skip count by that number. Let's start with 2 because it's easy to skip count by 2s. 2, 4, 6, 8. That's the first 4 factors, so let's stop there. Next, we'll skip count by 8s to find the first 4 multiples of 8. 8, 16, 24, 32. And if you can't skip count by 8, you can use repeated addition, or you can use a multiplication table to find them. Now we want to look for any numbers that are common to both lists. Do you see any? What number is common to both lists? Did you say 8? If you did, you got it right. 8 is the only number common to both these lists, and it is also the least number common to both of these lists as well. That makes it our least common multiple, or LCM. So now we know our LCM is 8, and that becomes our target denominator. Now we need to change 1/2 into an equivalent fraction that has 8 as its denominator. To do that, we have to figure out how to make 2 turn into 8 using multiplication. In a way, we're trying to solve this equation. What number goes in the box to make the equation true? Did you say 4? That's the right answer. Now we know we need to multiply 2 by 4 to get a common denominator, and whatever we do to the denominator, we also have to do to the numerator, which gives us 4/8. Now that we have a common denominator, we can simply add the numerators and we end up with 5/8. Up until this point, we've worked only with fractions that had related denominators: halves and fourths, thirds and ninths, halves and eighths. In each of these examples, one of the denominators was a factor of the other. But how can we solve problems involving addition of fractions when the denominators are unrelated, like, say, thirds and eighths? We know that to add fractions, all we have to do is to find a common denominator and then add the numerators. In this case, the denominators are thirds and eighths. So what is the first step in finding a common denominator for thirds and eighths? Did you say we need to list the multiples of both 3 and 8 and then find the first number that's common, meaning it's on both lists? Yes, that's it. Let's go. Here are the first 10 multiples of 3 and the first 5 multiples of 8. Did you spot the least common multiple? If you said 24, you're right. Okay, so now we need to use that least common multiple to make both fractions have the same denominator, which will be the LCM we just worked out, which is 24. To make 3 into 24, we'll multiply it by 8. And remember, whatever we do to the denominator, we must also do to the numerator, so let's multiply the numerator by 8. 8 times 1 is 8. So our new fraction, which is equivalent to 1/3, is 8/24. Now we do the same thing with the other fraction, 3/8. We multiply the denominator by 3 to get 24. Then we multiply the numerator by 3 as well, which gives us 9. This gives us 9/24, which is equivalent to 3/8. Okay, so now we have two fractions with a common denominator, so we can just add the numerators to get the sum. 3 plus 9 makes 12, so our sum is 12/24. Now we're not done yet. Look at the fraction 12/24. Do you think that this fraction is written in lowest terms? In other words, is it simplified as much as possible? No, it's not. How can we tell? Well, we look to see if both the numerator and denominator have a common factor, and we can easily see that both 12 and 24 are even numbers, which means they both have 2 as a factor. Remember, having 2 as a factor is the literal definition of even numbers. We could divide both the numerator and denominator by 2, which gives us 6/12. But if we look at this fraction, it definitely isn't in its simplest form either, because again, both the numerator and denominator are divisible by 2. So we're going to need to find a bigger common factor if we want to simplify this fraction. In fact, we need to find the greatest common factor, or GCF. To do this, we're going to list out the factors of both the numerator and denominator and look for the greatest common factor, or the biggest number that's on both lists. Here we go. Okay, what's the biggest number that shows up on both lists? Did you get 12? Good job if you did. This tells us that we need to divide both the numerator and the denominator by 12, because remember, whatever you do to the numerator, you must also do to the denominator. And that gives us 1/2, and we're done. Okay, so we know how to add fractions with unlike denominators. How do we subtract fractions with unlike denominators? Well, luckily, it works exactly the same way. We find a common denominator by identifying the LCM, in this case, 12. Don't forget, whatever you do to the denominator, you must also do to the numerator. Now we have a common denominator, and all we have to do is subtract the numerators. 9 minus 4 equals 5, so our difference is 5/12. I hope you found this video lesson helpful and have fun adding and subtracting fractions with unlike denominators.